As I said before, I wanted to talk to you about data sources. So when we're talking about a big data project, what are the data sources? Where does the data come from? So it really depends on the project and the use case, but I can talk you through some typical answers to that question. So for example, sometimes it's literally just from a transactional database. Sometimes it's from a cloud SQL database if you're in Google Cloud, or just from a SQL database if you're in Azure or in AWS. Any kind of transactional database can be the source. But also NoSQL databases can be the source. So what's a NoSQL database? So a NoSQL database is, you might have heard of Mongo or RavenDB. Mongo has an Atlas variety in the cloud. You might have heard of DynamoDB or some of the Cassandra type DB NoSQL database flavors of Cassandra. So there's a lot of different kinds of NoSQL DBs. Now, what do they have in common? Well, what they have in common is that they're not SQL databases, okay? So they're not relational databases. So what's a relational database? A relational database is typically a set of rows and columns in a table, and that table might be related to other tables by keys, by foreign keys, and so on. That's a typical SQL database. So SQL is SQL, and SQL is the query language, the structured query language that you use to get data out of a relational database or a SQL database. So with NoSQL databases, how do you get the data out? So first of all, NoSQL databases have two main types. One is a document DB type, and the other is a key value pair DB type. So what's the difference between those? So typically a NoSQL database that is a document database will have all of the data pertaining to a particular entity all stored as one big document. Now, in some cases that's great. So for example, in a medical situation, in a health record situation, whenever you access a patient's record, you're typically going to access the whole of the patient's record. You don't want just a piece of it, you want the whole thing. So that makes great sense to be in a document database, because whenever you retrieve that data, you're always going to retrieve the whole thing. And there aren't that many relationships in that data that are external to that document. So if there aren't many relationships that you need to model in your database, a NoSQL database, a document database is a really good idea, okay? In a NoSQL database that has key value pairs, that's often very small pieces of information stored in what's called JSON format. JSON is JavaScript object notation. So basically the information that you're storing is really being stored as an object instead of a table. So in relational databases you have tables, and in non-SQL databases or non-relational databases you have typically, you know, documents and objects. That's pretty much how it is. So the objects that you're storing in these key value pairs, the key value pairs tend to be almost like in a table in a relational format where you would have a column. The column would be the name of the key value pair or the key of the key value pair, and then the value for your particular entity would be the value in the key value pair. So for example, a key might be name and the value might be Michelle Solicitor. A key might be age and value might be 55, that kind of thing. So that is a key value pair. Now, key value pairs are usually stored as JSON, as I said, and JSON is very easy to manipulate in most programming languages today. And there's all kinds of special packages and stuff to use JSON in a really optimal way. And there's something called Bison, BSON, which is it's kind of based on JSON but on steroids, and it makes it really easy to get data from, say, a Mongo database or what have you. So that is the key difference between those two different types of data sources. Now, another data source might literally just be a thing. And what is a thing? So you might have heard of Internet of Things. So Internet of Things just basically means lots of things out there that can send data to the mothership. I call it the mothership. We call it the IoT hub in the cloud, typically. So the mothership is the IoT hub, but out there are lots of things. Now, the thing might be your phone, your cell phone. It might be a sensor on a piece of equipment, on a car, for example. It might be what's called a Raspberry Pi, which is a small computer that can sit on just about any device and send information into the mothership in a really clever way. It uses Python typically, senses information coming in at the ports, and the ports are kind of the gateways into a device, and that information can be sent to the mothership. So in an IoT situation, the device, the thing out there, and this can be like a thermometer, it can be a security camera, it can be a solar panel with a chip on it, it can be a wind machine, a windmill with a chip on it, with a little Pi. It might have a Raspberry Pi on it or a little device on it, any kind of sensor, that kind of thing. All of that data can be coming in what we call real time. Now, real-time data is a very big data problem, and often the data comes in so fast we can't even process it in time. Okay, so it can come in so fast and in such high volumes, and it can be different varieties because different things have different shapes in which they send data and that kind of thing. So this is the typical big data source of data. And what happens typically is the data comes into an IoT hub, and the IoT hub is really like a pre-data lake. It kind of takes in the data and it stores the data in such a way that it has a shadow of the device. So the device out there that's doing the sensoring and what have you, they often go offline by accident. They're wireless devices typically, and they go offline through all kinds of things. The wing changes, or the sun changes, or the device, the batteries die, that kind of thing. So the IoT hub will typically have a shadow of that device, which basically means it stores the latest status it knows about of that device, or the latest data it got in from that device. So then the IoT hub is what actually communicates with the big data process after that point. So it's almost like the first data lake stage, if you like. So typically from the IoT hub into the cloud, you would have some kind of real-time stream. Now, what's a real-time stream? A real-time stream is where data's coming in really, really fast, and you may need to do a little bit of processing, or you may need to put it on a queue so that it doesn't overwhelm the cloud architecture, the other components that are going to be processing the data. So basically, the real-time data streaming can be something like Kinesis data streams in AWS, or Kinesis Firehose in AWS. Firehose is a little bit slower than data streams, but Firehose is typically where you've got a bit more processing to do before you store that data. So typically at the end of Kinesis, you're going to have a storage mechanism, normally a data lake in a S3 bucket, something like that. So that's one kind of data stream. There are all kinds of other data streams. There's Kafka has Confluent data streams, for example, in the cloud. There's all kinds of different Kafkas. There's MSK and that kind of thing, but they're pretty similar. Kafka is pretty much messages coming into the cloud or into your system in a sort of a managed way, and it depends on your scenario how that's going to be managed. That can be almost like an ACID situation where you know, if you get a message in at this end, you know for definite you're going to get it at the other end, and it's going to be the whole message and nothing but the message and all that kind of thing. So Kafka can do that. It can also do a whole kind of event mesh, if you like, so that one message coming in at one side can set off a whole load of events on the other side, and even a whole workflow and all that kind of thing, a whole data pipeline maybe, depending on how you set it up. So Kafka has those kind of properties, and each of the clouds typically has some kind of architecture that either mimics Kafka or is actually using Kafka under the hood. And it normally starts with the word event, or in Google Cloud it's pub sub is typically the sort of poor man's version of Kafka, if you like. But it basically does a lot of that queuing mechanism. So basically the cloud architecture doesn't get overwhelmed by how much data is coming in from the left-hand side. So that's really what the data sources look like. So the data sources originate from either a SQL database or a NoSQL database or a thing. And a thing, typically the thing is going to be throwing data in very fast, constantly. Sometimes it could be things like stock figures on the stock market, or it could be weather data, you know, sensors telling you what the heat is like in a particular area of the country, and you can imagine that will be coming in all the time. Literally real-time data. Every second you probably get an update, and typically that data is going to be stored in a JSON format. It's key value pairs typically, because that's just a really nice format for those kind of devices to use. And then that data goes through some kind of architecture to get into that data pipeline we talked about earlier. So that might be through an IoT hub in an IoT situation, or it just may be a data lake. It may be something like Informatica or Talend, which they are data pipeline tools pretty much, and they take data from one format and move them to another format and typically store them in a different data lake typically. So that's data sources. So I hope you've enjoyed this session on data sources in the cloud, and I look forward to the next one.